Hey guys, welcome back to another video in C programming course. Myself, I'm Anand Samnohar and I'm a campus co-founder. So without any further delay, let's move on to today's agenda. Today's class we're going to discuss about static and dynamic memory allocation, and this is what we're going to discuss, and it's going to be like more important in the C programming language, I can say. So let's discuss about it, and then let's explore more on it, and even uh, we'll start from the very beginning, like what is a memory and all those things. Let's explore it, and then let's move to the static and dynamic memory allocation. So no need to worry about it. So let's get started with this. So before that, let me actually show you one thing here. This is the article that I have written on the same thing, the same topic, what we are discussing in our today's class. So this is static and dynamic memory allocation. So this is like I just want to show you this thing, and even you can have a look into it, and even I can show you like the pictures here, so so that I can actually explain you more better. So that's what I just opened this particular article right now. So even you can have a look at it for regarding this. You can have like kind of material thing like a reference for you. Whatever it's going to be more useful for you. Just have a look into it. I just go to this particular link, static and dynamic memory allocations in C. It is in the published in Greek for Greeks. You just have a look into it. So now, coming to the before actually jumping to the static and dynamic memory allocation, I would like to actually talk about memory. So what is mean by memory? So before actually jumping to the static and dynamic memory allocation, let's discuss about the memory. So basically, memory is divided into small addressable units called bytes. So for example, assume that this particular boxes are called bytes, and each byte has its own address like this. For example, here we have it like a 0 1 2 3 4 5 6 7 8, so like address. Well, as I said, in our memory, like there is a lot of memory. Like for example, if you could say in my memory, uh, my RAM is equal to like 8 GB RAM. So it's going to be like huge amount of it. Like we just only consider as a bytes in our program, right? Like whenever we variables, like it's going to store, like it's going to be like storing like in a variables, like in a bytes. So it will take like huge amount of memory that we have. So as per the program, so in that case, it's not possible to like if the directly store it in the somewhere in the memory, and then how can we can retrieve the data again when we want it, right? So that is the purpose we have it like everything inside the memory. We going to calculate in like we going to make it as like address. So that address, we just call that particular address, and then we'll get the data as we already look into in our pointers concept in our previous class. At the time I already explained to you regarding it, so that yeah, that's what like pointers, and if you know all those things, then you can actually understand how it actually works internally. That is what all these concepts you can't get it in like some other languages, like some other programming languages. um, you can't even find this pointer concept, and it's all those things. That's what in C, whenever you as a beginner, it's better to start with the C, so that you can actually understand all those things. So that's why I would prefer C. So here, this is like this is assume like it's a memory, and then we have like small address units, and each box has an address like 0 1 2 3, like that is going to work internally in our memory. And now coming to this, and then how program uses a memory. So basically program, let me actually zoom it out. So for example, now how program uses memory. So memory actually basically divided into three sections. One is code section, one is stack section, and another is heap section. If you could see, these are the three sections that we have in our memory. So this is like assume this is a memory, and in memory is divided into three sections. One is code section, stack section, and heap section. So in code section, whenever you write the code, and then whenever you run that particular code on your computer, like as we like right now we are just running in our code blocks. So the same way, if you run the particular code in your code blocks, that actually that program, everything going to store inside this inside heap memory. I mean, sorry, inside main memory. Particularly in code section, it everything going to be stored inside the code section. The whatever the code we have written over there, everything going to be stored inside the code section. Now coming to the what is stack section. So In stack, variables are declared and stored and initialized during runtime. Like whenever we declare a variables and whenever we write a functions, not only variables, even functions or anything, everything going to store inside the stack section, and it everything going to store during a runtime. But when it comes to heap, it's going to be different. That also we're going to discuss right now, so no need to worry about it. So it follows this first in, first last out method. So stack is nothing but first in, last out method. So like even you can also explore more on this stack and all those things in our like data section when you actually learn about data section algorithms. At the time you're going to learn it more on the stack, but right now I just want to tell you how it actually works in our memory. So that's what I actually want to say. Like whenever the element is going to store, that actually whenever we actually declare variables, and whenever we declare the variables, or whenever we actually initialize our functions or anything, everything going to get into inside this particular stack. Even that is actually more about the stack, I'm going to show you in our coming things, so no need to worry about right away. So that's what like you actually going to understand everything what you want at end of the class. So don't need to worry and don't skip the class. So now coming to the heap. So heap, just I just want to give like some overview. But when we actually going to look into the with the example, at the time you're going to understand more about it. So no need to worry it right away. So heap memory is cannot be directly used with the help of the pointer only. We can actually able to use this heap memory. We can't directly access the heap memory without pointer. So only with a pointer, with the help of pointer only, we can actually able to access this particular heap memory. So that also I'm going to show you right away. So no need to worry. Just keep in this mind. So but when we actually talk about the example, so that you can actually understand what actually I said right now. So that's what when we actually talk about the with an example, at the time you're going to understand. So now let's talk about the static memory allocation. When we actually talk about static and dynamic allocation, so you can actually better understand this stack and heap memory and how it actually works and everything. We're going to discuss more on it. So no need to worry about it right away. We're going to discuss it with examples, and then at the time you're going to better understand what we're actually talking about and everything. So no need to worry right away. So that's what I just want to show you right now. So now coming to this static memory allocation. So static memory allocation is nothing but like whenever the program execute, it fixes the size that the program is going to take, and it cannot be changed further. So exact memory requirement must be before. That is nothing but nothing but static and like allocation and the deallocation of the memory will be done by the compiler automatically whenever everything is done at compile time or before runtime is called static memory allocation. What does this mean? So let's actually explore it more on it. So with an example. So, for example, here, yeah, as I said right before that itself, it's a C++, but don't need to worry. There's nothing but difference with C and C++ for this particular code. I'm saying. Only thing is like we just change this header files, and then we don't use this using namespace std. Other than that, everything is fine. So here we have two variables, so integer type and then long type variable, and integer, as in that integer type take 2 bytes, and long type take 4 bytes. And now coming to this particular heap and stack sections, let's actually explore it in. So whenever I run this particular code on my compiler, how it actually works is, so I'm not showing it in my compiler because like here we have a picture so that you can actually better understand how it actually works internally. So that's what I'm just saying it orally, but we'll also going to explore with an example, so no need to worry right now. So now here with this particular void main, and then here we have declared two variables, long is an integer. So now whenever we actually run this particular code, everything going to store inside this particular code section, but everything going to be stored inside the code section. But whenever we actually allocate this particular memory, we have two variables, one is a and another is b, and one is integer type and one another is long type, right? So whenever we run this particular code, everything going to be stored in the code section, and then the two variables going to be allocate the memory inside the main memory. So here in main memory actually consists of three different types of sections. So in the middle section there is a stack section. Here the data the variables going to be allocated memory. So like this way. So for example, here the A has 2 bytes and B has 4 bytes. So this is nothing but stack frame or activation record, you can say. Activation record. So is nothing but activation record is nothing but, so as I said before itself, even when we actually talk about in our previous classes, if you remember that, I think in the pointers itself, I guess. So in the pointers itself, when we actually talk about it, at the time when we actually run that particular function, mm, uh, whenever we run the particular call by value, I guess, yeah, in the call by value only, like when we actually talk about in the previous class, in the call by value, at the time we actually swapping two numbers. When we actually swapping two numbers, we have written the user defined function separately, and then we're not doing anything inside the main function. We're just calling the function, and then we're just doing it. But when we actually call that particular function, once the function is ends, after that we are trying to print the values, but it's not its swap at in the particular main function. Like when we are trying to print inside our main function, but it's not. We got the result as the same, similar to our whatever the values that we have mentioned here, A and B. The same values we got it in output as well. Not swapping anything. That because whenever in the stack memory, like when once that particular function ends, the stack memory going to delete this particular memory, whatever that have allocated the memory. For example, here the A and B, 2 bytes and 4 bytes, total 6 bytes are allocated. That everything going to be automatically deleted. Everything going to be automatically deallocated by the compiler itself. We don't need to do anything else. Everything going to be done by the compiler itself. But when it comes to heap memory, that's going to be different. That we're actually going to explore in the like in a few minutes. So no need to worry about it. So this is what going to happen once we done with that function. That particular function, that particular whatever the memory has allocated, everything going to be deallocated, and like until now that going to be like activation record. So it will be like active, like it's a kind of active. So that's what it's called as activation record. So once it everything is done, it's going to be deallocated, and they're no longer available. The activation record is no longer available. So that's what actually going to work in stack memory. I hope you understand. So this is what actually works in the stack memory. Uh, so even let's actually explore more on this with an example so that you can actually better understand, so that I will also explain more on it. So let's actually start with an. I have created static and dynamic calculation, and this I just created some, and so this is the default code I got it. I just remove the default code, and then now here we'll take an example like integer type size here, and then printf enter limit enter limit of the enter limit of the text, enter limit of the text, and then here I'm going to use this scanf function, scanf function, and then ampersand size. So I'm just I'm just asking the user to enter the size limit of the text. So whatever the text they want to enter the limit, I'm asking size, so that I can declare with an array of character. So I'm going to mention this in this way, and then here I'm going to ask the user to enter some text. Again, I'm going to ask the user to enter some text, and uh, here what I'm going to do is let us Input a text in, yeah, input a text is, so this is what we have done. So let actually enter the limit here. For example, I'll just enter limit something like 50. So here actually it's not actually asking me to the enter some text. It's actually not taking me the. It's not at all taking this input. That because actually happening. Here we have to do this scanf from space here. As I said, so whenever we take inputs in like the integer type, and then we suddenly take the input for this character type or string type. So at the time, I'd actually make it as in a buffer class. So regarding the buffer, I already explained in our previous classes. If you haven't checked the video, please do check the video and then come back here so that you can actually better understand these things. And even I have shared some resources regarding these buffer things, buffer classes. So you can actually go and check the previous video, and then so that you can actually understand more better why we are actually using this scanner function here within double quotes. So now let actually run it out. So now here it actually asking me to enter the limit of the text, and then it asking me to thanks for. Okay, we got it. This yeah. So that actually happened because here I haven't mentioned this percentage s here. So now when I run this particular code here, now it actually asking me to enter a limit. I'm going to enter 10, and then it asks me to enter. So now we got this thing. Whatever I have entered, this is, and then now input text is also this is. That's what we got it in output screen. So this is nothing but an example for static memory allocation. So here everything going to we actually mentioning here. Actually, we are not using anything, and like as I said in our example. So here, whenever we actually do this, this is a normal thing. Like we have been doing since from the beginning of the C programming series. Before actually not aware about the static and the dynamic allocation itself, we are actually doing following the same thing, right? The same pattern that we are following from the very long time. So here we actually mentioned this integer size, and then asking user, and then we actually mentioning everything going to be allocate memory inside the main memory, inside the stack memory. So all the things going to be allocated inside the stack memory. So this is nothing but a static memory allocation. Everything run um, like everything going to be done by the compiler. So allocation and deallocation of memory, as I said already in the example itself, I already explained you. So here this particular thing, for example, here once everything is done, everything going to be deleted by automatically by this compiler itself. So we don't need to worry about anything else. So everything will be done by the compiler itself. So that is nothing but a stack memory. That is nothing but a static memory allocation. So the like whenever the program executed, it fixed the size itself, and that program is going to take, and it can't be changed further. So whenever we are here itself, we're actually mentioning this particular size. We're actually mentioning this particular size, and then we are just fixing this particular size, and it can't be changed in the further program, like in this particular line. If you want to change the size again, It's not at all possible in the static memory allocation. That's what the definition says, whatever I have mentioned here itself. So whenever the program executes, it fixes size that the program is going to take, and that it can't be changed further. So the exact memory requirement must be known before. That's what we actually explore right now. And this allocation, deallocation of memory will be done by the compiler automatically. Everything will be done by that. So we're not storing anything inside this stack section or anything. Just everything will be done inside by the compiler itself. It's everything will be done backgroundly. We're not doing anything else. That's what I mean by static. So when everything is done at the compile time or before runtime, so this is what everything will be done like by the compile at compile time. So everything will be done by the compiler itself. That's what we actually explored right now. So this is nothing static memory. So I hope you guys understood. And even this example is like this is nothing but like as we have been using this particular thing from long time. That is nothing but a static memory. So we have been using it from long time. Before actually we are learning about static, but right now we actually learn about static. So what is mean by static? So now coming to the dynamic memory allocation, this we haven't learned before, but right now we're going to explore more on it. So like explore about it. So dynamic memory allocation, size, initialize, and allocation are done by the programmer. So everything going to be done by us, so not by the compiler. And it is managed and served with the pointers that point to the newly allocated memory space in the area which we call the heap. And heap memory is unorganized and treated as resource when you require the use of it. If not, release it when everything is done during runtime or execute time. It is known as dynamic memory allocation. This is what we're going to use. Like once we're done with all the examples that we're going to do, and then again come back to this particular definition so that you can actually understand whether we have covered all those things or not. Even if you didn't get that, don't need to worry. Let's actually explore more on it with examples so that you can actually better understand. That's what I feel. So here there are some functions available in stdlib .h header file, which will help you to allocate memory dynamically. So this is what we have been using this particular header file, but we haven't utilized the particular header file. But its default the compiler is giving us, but we haven't used it at all. But we're going to look into it right now. Some of the functions available inside this particular header file. So okay, and now here these are what are the header files that are available. I mean, that what are the functions that are available inside this particular header file that we're going to look into right now. So one is malloc and calloc and the realloc free. These are the functions that we're going to look into right now. So what is mean by malloc? Everything we're going to look into by the like example also, but rest let us discuss with the definition as well. The simplest function that allocates memory at runtime is called malloc. So this is nothing but malloc syntax. It's nothing but we actually allocating the memory by ourselves. For example, here when it comes to static memory allocation, here everything going to whenever we declare this two variables a and b, everything will be done by themselves, right? But here when it comes to here, we going to allocate by ourselves by using this particular function, the malloc function. And this is a syntax for the malloc function, how to use it and everything. So this is nothing but malloc. And even calloc also function offers a couple of advantages over malloc. It allocates memory as a number of elements of a given size. That is what it difference. I mean, when we actually look into it with an example so that you can actually better understand, that's what I would say right now. And then this free memory is allocated dynamically. It should always be released when it no longer required. As we said, when we talk about the static memory allocation, everything going to be allocation, deallocation, everything would be done by the compiler itself. We're not doing anything else. But when it comes to here, dynamic allocation, we have to delete that particular deallocate the memory and then allocate the memory. Everything would be done by the programmer itself. So deallocation also we're going to do it by ourselves. So that is what we're going to do right now. By using this for deallocation, we're going to use this particular function free. For allocation. we're going to use malloc and calloc, and then one more function that we have is realloc. As I said, when it comes to static memory allocation, we should must and know that how much memory it should take. We have to declare before like before the program, like the beginning of the program itself. If you know what is how much memory that actually takes and everything, if you know already aware about it, then you can go for static memory. But if you're not, like first of all you want to declare something else and then you want to reallocate accordingly, if it is more than that, then you can go for dynamic allocation. Here we have more options like reallocation. We can also reallocate the memory. First of all, we're going to allocate memory using malloc, and then we can also reallocate using the realloc after some time in the C program. That's what the use of reallocate function. That is the syntax for the reallocation that we're actually going to explore with an example so that you can actually better understand with it. Uh, for a small example, like we can say this particular thing. Um so this is what thing is. Really, actually, it actually start with an example, so that will come again and then explore this diagram so that you can actually better understand what which I'm talking about these things. So let actually explore with an example here. Let me actually write it like this. Static here. Let me comment it out. Dynamic. I'm going to write a dynamic here. Here, let's actually start with an example for all the threes, like whatever we have discussed in now. Mloc, cloc, realloc, and free. For four functions we have discussed. All these functions we're going to explore right now with one example, so that you can actually better understand all those things. And then even after once after we done with this example, and then well let's head back to this particular diagrams which I have shown in this particular article. So and then I'm going to show you with this thing and that thing. You can actually better understand with this. So here let's actually start writing with this particular thing. So now here I'm going to declare two variables. Before that, let me write main function. Sorry, I haven't tried main function. Yeah, main function. Mm. So main function, inside main function, I'm going to write mention this integer size and then resize. Resize. So this is what we have two variables. One is size and then another is resize. So here and then here initially we're going to store like here also we're going to take it as like the string type only, not this something else, the numbers or something else. That's what we have been doing with normal numbers and everything. But here I don't want to do the same thing, so here we actually take some string type only. The character again string equals to null here, a null. And then for initially I just declare with a this is a string pointer, str pointer. So this is not but str. So like str in the sense string, you can assume a string. I just have written in a shortcut, but yeah, I'm just using a pointer here. That's what I have to remember. And then I'm not pointing to anywhere, I'm just have mentioned null initially. And then here I'm going to ask the user to enter the limit of the text, scanner function percentage d, and then ampersand size. So here have asking the user to enter the size, and then once after the entering the size, I'm going to the str and then we already declare the pointer, the character type pointer. So here just taking that particular pointer variable. So and then so here I'm going to use this malloc function that we